All right. Good morning. We are in week 4, day 4. I can't believe we're a month through already. Time's flying by. So this week we've been going through classes, and on Thursday we covered inheritance, introducing inheritance in classes. Today's README, oh, I was halfway through it. I didn't even realize. If you want to pull it up, we're pretty much going to be following closely with this for today's lecture, except at the end I will build upon the example we did last class with boxes to try to drive it home, this idea of inheritance. So we remember we had a programmer and an accountant, and we decided since they shared so many attributes between the two classes that we wanted to use inheritance to like set up those shared attributes in its own class, which we said was an employee, and then just kind of borrow those already defined attributes within programmer and accountant. So that's what we did last class. We looked at how we had a base class, which was our basic employee, and programmer and accountant inherited from that base class and can use those attributes and methods that that class had. Of course, we had to use the super init method to be able to access any of those attributes and methods in the base class we wanted to use. So today we're going to build and see that not only can we do inheriting from one class, we can inherit from multiple classes, which can be pretty useful in certain situations. The example in my README, and the README here, we're going to start out with fruit, okay? Fruit is definitely its own thing, banana, apple, raspberry, what say you? So we're going to have our class of fruit here. We have our initialization method that we have to call. Again, thank you, VS Code. We leave self in there. Self is in any class we initialize. And we're going to have a name and I guess plant. We'll roll with it. I guess wherever the fruit comes from. We identify these attributes underneath because just because we initialize with them, we have to tell our class how they're being used, basically. So we've got them down here. All right, so now we have a fruit class. And this fruit class, whenever we make a new instance of it, we can give it a name and a plant that this fruit comes from. So on the other hand, I have pies. We love eating pies. Pies are definitely their own thing too. We're going to go ahead and make an instant or make a class of pies as well. So far, nothing to do with fruit. It's definitely a pie is not a fruit, so I'm not going to take anything from this. I want it to be completely separate because yes, a pie can inherit a name, but pie doesn't have a plant it comes from. So I definitely don't want to take anything from this class into my pie. It's going to be completely separate. But we do still have a name. But I decided, I don't want to inherit anything from this because it doesn't make sense. So I'm going to just go ahead and make a name for this class instance. And it has ingredients that we put in there. And we do the same thing. Oh, let's pause. Does anybody know what pass is? When VS Code just throws this in here. I would guess, oh, go ahead, Cisco.
Oh, and it's just a way to uh bypass the function or yes, just a way to bypass the function so you can continue testing out other functions. It's kind of like it's kind of like putting a comment inside of a function, say to do later or something like that, and moving forward. You're fleshing out the functions as you go along. So,
Right, exactly. So if I didn't have pass, this is going to throw some errors and issues. It wants to resolve this function. It at least wants a return statement, which we could do a return as well, but that would give a return of nothing. And it's just kind of, we just don't want this function to run right now. We don't want it to do anything because we're building it. So what pass does is it ignores this function, basically. It won't even try running it. It comes down here and sees pass and just automatically skips to the next thing. So VS Code puts that in there as kind of helpful code so you can flesh out things, but you don't want to leave that in your block because then your function will not run. So we definitely want this to run though. We want to take our name and assign it to the name we're passing in when we initialize this class and our ingredients as well. Did I spell ingredients wrong? I sure did. It is too early. Ingredients. Okay. Perfect. So now we have our fruit and we have a pie. However, we all know apple pie is amazing. Everybody loves good apple pie with some ice cream on top. And when we think about it, that definitely has things from both of these classes, right? An apple pie is going to be a pie for sure, hands down. But it also has apples in it, which is a fruit. And we'll share some attributes of this because when I make an apple pie, I can say that there's an apple that comes from an apple tree in this pie, and it's kind of part of the ingredients too. Like we throw apple in there if we want, and flour, whatever else, butter goes in pie. So here is where the multiple inheritance comes from because I am making something that kind of combines two things I've already initialized. So we're going to make now a fruit pie. And with inheriting, it's the same as we did before, where you'll pass in the base class you're inheriting from. However, we can just string together, separated by comma, each class we want to inherit from in this instance. So we have fruit and pie. Now, order matters with how you inherit. And we'll see that more later in class. But for now, let's just keep in the back of our head that when we pass in our base classes, you want to kind of assess the order in which you're passing them in. I'll kind of walk through that in a later example in the lecture here. Now, I'm inheriting from two base classes. We know we have to do a super init, right? In order to access any of these base classes. How can I super init from two classes? Seems kind of tricky. Like maybe, what is your first instinct that we should do for our super init? Let's go ahead and I wonder if VS Code is going to be helpful and tell us. Well, maybe I have to get further along. Super underscore init. Or I've messed it up too much and it's not going to be helpful. Okay, no, it's not going to help you today. So this is our structure of our super init. What did we do when we just had one class we were inheriting from? Does anybody remember what
we we added the parameters of that one class.
Mhm. Exactly. In the super init, I don't know if this is going to be any helpful information here. Nope, we added the parameters that we were inheriting from the parent class or the base class, sorry. So let's look at our parameters. We have name and plant here. We have name and ingredients here. So we can, let's see, if I were to just add, it looks like we can do name, plant, or not, yeah, name, plant, ingredients. Why is my super init being weird? Oh, because I didn't define an initialization here. Okay, let's put a pin in this. That's one of the important things. Okay, so let's put a pin in that. We gotta define initializing this class first to begin with. All right, can't have a class without its own initialization. Oh, so it looks like it's very helpful here and tried to give us a whole bunch of with our super as well. Okay, so we have our class is going to have a name. It said it wants to get plant two. Look at what it pulled in with just this helpful code here. If we compare with these two, which class did it pull in attributes from?
Fruit.
Yep, fruit. And if we notice, fruit is the first one in our list here.
Mhm.
So automatically it's going to look at the first class that we passed in and try to pull those parameters. But we also want ingredients from pie as well. So all we have to do is throw in ingredients here. And of course, we're going to have to put it in our superinit because it's not part of this class, it's inheriting from the pie class. So we see we don't have to put name in twice. Name we're only actually getting from fruit. So when I make some pies, it's probably going to have like the name of the fruit, like apple pie, whether fruit pies, instead of taking the name from the pie. Just because of how classes inherit and the order. Oh, I only know the acronym right now. I'm going to have to Google real quick what it stands for. But this is called the MRO, which is Method Resolution Order. I guess it doesn't have much to do with the attributes, but when we look at methods underneath the classes, you'll see how the methods are resolved underneath each class, how it looks to pull what it's going to use within itself based on how we pass in the base classes. So this is an example of multiple inheritance. So this class here is getting attributes from two different classes. And it can use all these attributes because we passed in both classes for it to be able to use those. All right, next up, we're going to do multi-level inheritance. This one's a little less common, but still important to know. And we're going to get kind of scientific here because it uses family, genus, and species of animals. Art, you have a question before I move on?
Yes, if I understood you correctly, the name in the class of fruit pie is coming from fruits. But if you wanted to designate it that you wanted the name from pie, how would you go about that?
Well, so in this case, it does not matter because the name is just going to be whatever we initialize into this class. So actually, I can pass in the name fruit pie, and it's going to be, we're just saying that we want it to behave like this. If we pass in a name, we want it to define self.name is going to equal what we pass in as name. So in this case, it doesn't matter because these both behave the same way. But if there was a parameter that acted differently down here, let's say this was not name, but instead, I would not name it the same thing if you wanted the attributes to act differently.
Okay, I think I understand. So if it was hard coded, it would be different. But because it's generic like this, it doesn't matter.
Yeah, like what these classes are doing in and of themselves matters, but not for when we define this fruit pie. It's going to be a fruit pie class, right? So if let's go ahead and make fruit pie one. Can't remember conventions with Python. Is it camel case or snake case? I think
Snake case.
okay. Snake case. So we'll do fruit pie one. Equals, we're going to call an instance of fruit pie and we need to pass in name, plant, and ingredients. So I'm going to say apple, plant, apple tree. I don't know what it's looking for there. That's so weird. And ingredients, it's going to be a list. We're going to not string. So in a list, we have sugar, flour. So this type of thing. Okay. So then if I were to initialize like this fruit pie is going to have all these attributes. It's not saying that we made an instance of fruit called apple. It's just kind of borrowing this behavior where when we pass in apple, we're going to give self.name equals what we passed in. Does that make
Okay,
sense?
it does. I understand. Thank you so much.
Mm-hmm. Okay, great question though. If this behaved differently, it would have a different name probably. Because right now it's acting exactly the same. Maybe this is category. This would be weird, but this can be possible. Now, the category of this pie is going to be whatever we pass in under name. So if I wanted it to behave differently, then this won't work. This is going to look up here first in the first one we passed in fruit, and it's going to use how this behaves. So that's why we usually naming conventions, we try to name, I would change this then to category, in category. And we'll kind of play with that when we do methods in a bit with inheriting. So hopefully that didn't confuse more. But let's say I didn't want to do a name, I just want a category. Oh, we're not going down this road. I want to do this so bad, but we're not gonna learn this way. We're gonna inherit everything from our base classes. It's possible, and Justin and I were talking about it, but it's just a little more complicated than we really need to know at this point. There. So now I can definitely access this behavior in my class. So then I'd have to throw in a new, like, this would be like fruit pie. Right? Okay. 1, 2, yep, second. Very good question, and definitely something we're touching on with the methods in a bit. Okay, so multi-level inheritance. Not too difficult to understand as long as we kind of get how this goes, where you can inherit from multiple. I am just copying this code chunk because I don't feel like writing all these names. This is straight from the README. Okay, so let's take a look at this. We have our base class because it's not inheriting from anything, right? There's no parentheses afterwards. It's its own class. This family has a family name, and it's initialized here within the instance. We come up to this next class, genus. It is inheriting from family. So it's going to have our regular initialization, where we have a genus name, which is unique to this class, and a family name, which we inherited from family. Because we inherited it, we need our super initialization here with family name passed in. And then because genus is specific to this class, we identify it right here. Now, when we get to species, species inherits from genus. But look, it has a family name. So it can do this because when we inherit from genus, genus is inherited from family. So it just automatically has access to everything that genus has access to. So we don't have to pass in multiple. We can just pass in the one that inherits from the other. So here I have access to everything. So I have access to genus name, which is from genus, family name, which genus inherited from family, and species name, which is unique to this class. In our super init, we still have to identify every attribute we're inheriting through the grapevine, basically. So not too hard to understand, right? So then if we make, like they say, if we give a species class dog, it will inherit the genus name Canis, which inherits the family name, I guess, Canidae. So we can extend this also by creating a breed class, which inherits a species name from the species class and then gets its own attributes. Any questions on this? Okay. Why didn't we use that here? I want somebody besides Cisco to answer. Look at the two and how we're inheriting. Why couldn't I have just done pie inheriting from fruit and fruit pie inheriting from pie?
Because pie isn't inheriting anything from fruit.
Exactly. It's got nothing to do with fruit. There's no way we can tie these two together logically. So we don't want it to inherit anything from there. If we had name, we could still, if we had name still, we probably could get away with this, multi-level inheritance, but it still just doesn't make sense. A fruit is completely different from a pie. They don't belong to each other in any way, shape, or form. Here, there's a logical kind of connection between everything, and that's why it inherits down the line. So good job. Exactly. Let's see. Now we're going to get into using multiple and multi-level inheritance all at once and kind of seeing how everything behaves in this lovely MRO and how everything's resolved. Because this was pretty easy to follow when we have like just a couple of places we're inheriting from or down the line. But it gets kind of crazy when we have a lot that let's see, we're going to comment this out because we're going to start kind of playing with this and instantiating some objects. Okay, again, directly from the README for this. So if you want to copy and paste and follow along and kind of watch how this is going in your own VS Code, we are down to this Rockstar example. So taking a look at this, we have a Rockstar class. Is this a base class or an inherited class? And why? Adam, your turn. Is this Rockstar base or inherited, and how can you tell? Oh, if you're talking, I can see your mouth moving, but you're muted.
Oh my
saw,
gosh.
I saw
Okay.
parentheses, so I'm like, yes, he's got it, but
Yeah, actually, exactly. That's what I was saying. There's no parentheses saying that like it's inheriting from anything, and there's no super in it saying it's inheriting from anything, I guess. Yeah.
Yep, awesome. 100% right on. So exactly. This is our base class because we haven't inherited from any other class. It's got its own initialization. There's no super initialization, and it has its own method right here, Rocco. Next class, vocalist. This, in line with what we just talked about, is inheriting from Rockstar because we passed it in here. It has its initialization. We know name is inherited because it's in our super init. And we have Mike is something new that's specific to vocalist. So that's identified here in our initialization method. And it has its own rock out method. Interesting. Same name as this rock out method. We'll see how this goes. Guitarist, also inheriting from Rockstar. Okay, own initialization method here. Name though is inherited because it's in our super init. Guitar, something new to this class and specific to this class. So we throw it in our initialization method here. Also has a rock out method. Its own rock out method. And all these have different emojis associated with them. This could get messy. We'll see. Backing guitarist. Now this one, is this multiple or multi-level? Take a look at where it's inheriting from. with 2 in here right away, what can I say what type this is for sure? Oh,
Multi-level?
okay. Explain why you think it's multi-level.
Just because it's pulling from two different classes.
Okay. That was the um mul that is the multiple inheritance. So when we're pulling from 2 classes, it's multiple. Multi-level. How can we tell something's a multi-level inheritance? And that's what we did here with this family, genus, species. And anybody else can jump in if you all know. Multiple is passing in 2 or more. Multi-level.
Multi-level is when you have 2 classes that don't have anything really to do with one another.
Okay. That I would still say is a multiple inheritance.
Mhm.
Multi-level, if we come back and look at this, these are each only inheriting 1 class.
Mhm.
But when I inherit from genus, genus is inheriting from a different class. So that's where it gets kind of stacked in our inheritance. So
Mhm.
that's the multi-level, is when we're inheriting from a class that in turn inherited from a different class. So that's that level thing here. So going back here, we definitely got, this is multiple because we're passing in 2 classes, right? We're inheriting from 2. If we look at it, let's check out vocalist first. Vocalist is inheriting from Rockstar. So this would be that multi-level inheritance. So we're inheriting from vocalist, which in turn is inheriting from Rockstar. So we get kind of that stacked inheritance here. Same thing with guitarist. So it's multiple because we have 2 we're pulling from, and guitarist also, we come back here, guitarist was inheriting from Rockstar. So that's the leveling approach. So this is very stacked. It's got multiple and multi-level inheritance going on. We can see its inherited name because that is same throughout everything here. We've identified it up here in this initialization. Everybody's going to have a name, so we just kind of keep passing that through to every other class. We've got Mike. Why did we do this? Why is Mike not in our initialization? What's going on here? Because I thought since I'm inheriting from vocalist, if it has Mike, I shouldn't have to do this. So what is this doing in this class? If I were to, let's just go ahead and take a look at what happens. I'm going to make a backing guitarist, okay? So, well, no, this won't even be illustrated when I do this because, okay, let's just think about it first. If I'm inheriting things, do I have to define them within this own class? Did I do that anywhere up here when I inherited something? Did I ever go ahead and throw in within the initialization method?
Only when you had like a new variable or whatever it's called.
Yep, exactly. Only when I had a new attribute. So doing this, Mike, and then identify or defining it here within this initialization method, is this inheriting from vocalist? No, I see Nicole shaking her head no, and that's correct. This is not inheriting Mike from vocalist. We're not using the way this is written. Same with guitar. We're not inheriting from a different class. And this comes into play if, I think they say it in the README too. somewhere. No, they don't point this out at all. But sometimes if you just don't want, like we were talking about, if we don't want an attribute to behave in a way that a parent or a base class is behaving, you can go ahead and just define it within this class here. So this mic and guitar is completely unique to this backing guitarist. It has nothing to do with vocalist, and it has nothing to do with the guitarist. I don't know why we're doing that in this instance, but that is the behavior we're doing here. We're not inheriting these from the others. I don't think it matters, but it could if we're fleshing out a whole bunch of different things. But these are backing guitarist attributes. Again, we can argue if that's the right thing to do or not. Doesn't matter. I just want to point out that's what's happening. We're not inheriting those. The only thing we're inheriting actually is name and then all the methods underneath all these classes, right? We have rock out methods underneath several of these classes. So let's make a backing guitarist. Oh gosh, I wish I actually knew people's names to make it more fun, but I don't. So we're just going back with Bob is going to equal, he's going to be a backing guitarist. And his name's going to be Bob. So do I have, what does this mean where I have mic equals these empty strings and guitar equals empty strings? What am I doing with that here in the initialization method? Art, yes, question.
I understood the equal signs will allow you to set a default, but I'm not familiar with the parentheses. I'm not sure how that affects that.
Well, so let's think about it. If I just, what are these parentheses usually mean when we see parentheses?
You want a string there?
Yep, string, exactly. So it is setting, the equals is a default flag. So we're setting a default for this parameter. And when I hover over the parameter, you can see it says it's a string. So we are effectively telling it it's going to be a string, but we're giving nothing in the string. So it's basically empty and waiting for you to give it a value. However, if I don't pass it in right now, mic will be empty and guitar will be empty, which is fine. I don't want to pass it in. And the good thing is, because I've done this, it won't break my code if I don't pass it in. So this is a good thing to do if you have some attributes that maybe you don't always 100% of the time want to expect somebody to give. And it allows you to just have them be empty. You can have empty, you can have null, you can have, any number of like non-existing values. So 100% on the money there. That's a default. So I don't have to pass it in. I just need to pass in a name. And we can see that, let's see that here. The only thing that doesn't have a value is name. So I'm passing name in. If I call, let's see, and we have print. Okay, so that should work. I might have to print it. We'll see. If I call Bob rock out, what do we think is going to print in our console? Looking within this class. So this is where that method, resolution, order, or whatever comes in. And we kind of talked about this last class, is it looks in its own class first, right? And Nicole, you look like you were getting ready to say something. Did you want to take a stab at how it's going to kind of work out where to pull this rock out from?
I was thinking it was gonna first rock out it found.
Okay.
Right.
Yep, it's gonna get the first one it finds, so.
Before.
You're breaking up a bit, but I thought I read your lips. Is it vocalist? Is that what you said?
Yeah.
Okay. Yep, so I would expect that too, right? We talked about earlier that the order at which we pass these in is important because it looks at the first one first and then moves on to the next one. So with this class, we don't have a rock out. It's going to look here first. I defined a backing guitarist instance here, and I want it to rock out. It says, okay, let me look inside. I don't have a rock out. Let me go to my first bass class I'm inheriting from, vocalist. I'll look in here. It does have a rock out. So I would expect to see this microphone printed on the screen. Let's see if it prints. Yay, it does. There's our microphone. Perfect. But I don't want a microphone to print out because as a backing guitarist, I'm probably playing the guitar more as I'm rocking out. So this is where naming comes into play. There is in no way can I bypass vocalist, unless if I switch the order, these are passed in, right? I could probably do that. I could probably pass in guitarist first and then it would go here. But that's, I mean, what if there's something for vocalist I wanted to use first, you know, or a different method I had in here that I wanted to use first. I don't necessarily want to have to worry about the order at which I pass things in. So in that case, let's not name it the same thing. I don't want this to be called rock out in every single class because you're going to have a lot of, oh, I can't use, like, I can't even get down to rock star because that's going to be after all these basically. Well, it's going to be after vocalist, I think. It would go vocalist and then vocalist inherits from rock star. So it would go to rock star third. And then after that, it would go to guitarist. And look under guitarist and then look under rock star after that again. Confusing. I want access to everything I inherit at all times without worrying about how this order is going to unfold. Easy, easy fix. Give you names that are pertinent to the classes they're under. So let's not have rock out for every single thing. Let's have, for vocalist instead of rock out, let's have sing verse. When they're going hard, they're singing a verse. Okay. So now this method is something different. I can definitely call this and it's not conflicting with any of the other classes. Guitarist, same thing. We're not going to sing verse. We're not going to rock out. Here we're going to, what do they have? Guitar solo. Now I want the guitar solo because that's what that's what I want to do while rocking out for my backing guitarist. So now, easy way to go ahead and call it out. We could call rock out. Actually, if I call rock out and it kind of cheated there, it highlighted it, what's it going to print now? Joe, can you tell me what, if I run this right now, what is it going to print out on the screen?
The hand there from Rockstar.
Yeah, I like it.
Yeah,
Exactly.
what's it called again?
Ah,
I don't remember.
I don't know either. I didn't know I had a name really. I guess I kind of did, but exactly, that's it. That now is the only method we have called rock out. How it got there though is it started here, looked here, there's no rock out, went to vocalist first, looked here, there's no rock out. In vocalist, it inherits from rockstar, so it goes to rockstar next, finds the rock out then. So now if I want the guitar thing, again, easy, we can just do now guitar solo. And I should get that because there's literally nothing else called guitar solo. Oh, we didn't even, let's prove that rock out when we call rock out. Exactly. Any questions so far on multiple and multi-level inheritance? You guys are doing great grasping these concepts. So that will really help you out here. We can, do we want one more example? Building on the boxes thing I was doing yesterday, or do we want to just start kind of diving into the challenges for the day? I'm
I
open.
wouldn't be opposed to seeing one more if you guys are down, but to you.
This one shouldn't go long. There's really not much newness. It's just rinse and repeat how we're inheriting from different things. So if somebody doesn't want to watch, actually, so I'm gonna stop recording because I'm supposed to stop recording for extra examples. 1 second.